Hi, this is week 11 of chemistry, and in this lesson we're going to go over the following topics. We're going to begin with Lewis dot structures that deal with molecules that have more than a single bond, perhaps double or triple bonds. We're also going to talk about the Vesper model of the atom. Alright, so for our lesson objective, students will learn about the valence shell electron pair repulsion, which is Vesper, which tells us more or less the shape of a three-dimensional molecule. So we'll be looking at those. But first we're going to begin with bonding. Alright, so bonding. In a single bond, that has 2 electrons. But what if you have a double bond? Well, a double bond would have 4 electrons, and a triple bond would have 6 electrons. So each bond requires a pair of electrons. So that's why you see those numbers. Triple bond is 6 electrons, double bond is 4 electrons, and a single bond will have 2 electrons. Here the electrons are represented by the little squares here. Now, let's go to move on to our problem. Our first problem, they ask you to draw the Lewis dot diagrams for the following molecules, which you see right there. And before we get to those, it's very important to review the Octet Rule. The Octet Rule states that 8 electrons around an atom make an atom very stable. So ideally, atoms want to have 8 electrons. Now that rule doesn't apply to all the elements, and there are exceptions. In chemistry, there always seems to be an exception. But for the most part, it applies to elements in groups number 14 through 18. That's their minimum. They must have at least a minimum of 8 electrons around them. Now, some of those can form expanded octets, but that's a topic for a different day. So let's go ahead and get started. Carbon. Carbon's in column 14, so it's going to follow the Octet Rule. So they want 8 electrons around this atom. So I want to go ahead and have a quick discussion on the first one, carbon dioxide. Carbon dioxide, CO2. We're going to draw the Lewis dot diagram for it. CO2. Carbon is in column number 14, so it's got 4 valence electrons. And oxygen is in column 16, so it's got 6 valence electrons. Alright, so for a grand total of 16 electrons. Okay, so now draw the Lewis dot diagram. Carbon is at the center, and the center atom, we're just going to put it in the middle, put the oxygens around it, and now let's going to put all the electrons on the outside, and if there's extras, you put them onto the central atom. So the line represents a bond, so there's already 2 electrons there. So that's a single bond, 2 electrons there. So I'm already have 4 electrons in my drawing. So I need to get to 16. So this will be number 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, now we have 16. We're done. Well, actually not really. Why not? Carbon, it's in group 14, and every element to the right of it must have a minimum of 8 electrons around it. So far, if you look at this carbon, it's got 2 electrons here and 2 electrons there. It is not following the Octet Rule, but carbon must follow the Octet Rule. Again, elements in column 14 and to the right on the periodic table must follow the Octet Rule. So where do I get the extra electrons? I don't have any more. There's 16 already there. The solution, if you don't have enough electrons, then the atoms will have to share those electrons. So we're going to go ahead and take some electrons from the oxygens and share them with the carbon, and that's going to allow us to follow the Octet Rule. So I'm going to take 2 electrons from here and put them onto the bond right there. And I'm going to do the same on the other side. I could take any one of these. I'll just take the bottom ones and put them onto the bond. And now I've created double bonds. And I want you guys to notice that carbon now has 8 electrons around it. See, there's 2, 2, 2, 2, that is 8. So sometimes atoms make double and triple bonds, so that way they can follow the Octet Rule. And one more time, it is elements in column 14 and to the right that must have a minimum of 8 electrons around them. Alright, before I move on to letter B, I wanted to go ahead and do a separate problem that's not even here, just to give you an idea of double bonding. Alright, so I have MgF2, is magnesium fluoride. I go ahead and I get magnesium is in column number 2, so I'm going to put 2 valence electrons. Fluorine is in column 17, so I'm going to put 7 valence electrons, and I add them up and I get another 16. Alright, so keep that in mind, the same number of electrons. I draw that again, and I put all my electrons and it looks as our original drawing. Now, follow-up question. Should I move electrons to make double bonds, so therefore magnesium can have 8 electrons around it? Just like I did here for the carbon. The answer to that is no, I do not do that. Why not? As I mentioned, all the elements in column 14 and to the right, they follow the octet rule. Magnesium is in column number 2. It does not follow the octet rule. It does not want to have 8 electrons around the atom. So therefore, the drawing stays as is. This will be the correct answer for this one. Alright, now let's get to letter B. Oh, I wrote letter B, but that wasn't B. That was the one I made up. Alright, letter B, we have C2H4. Alright, let's count the number of valence electrons. Carbon is in column 14, so it's got 4 valence electrons, and there's 2 of them. And hydrogen is on the very first column, so it's got 1 valence electron. There are 4 of them. So for a grand total, that's going to go ahead and give me 12 valence electrons for this whole Lewis dot structure. Alright, so I'm going to begin with the central atom. There's 2 of them, but it's carbon who's our central atom. So there they are. Now I'm going to go ahead and I put the hydrogens. I'm going to spread them out. Here we go. Alright, now there's my drawings. 4 hydrogens, 2 carbons, just like that. Next, I need to have 12 electrons. Okay, so I have 12 right there. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where do I put the other 2? So as I say, there you go, 11, 12. Now remember, something we've talked about is that the electrons, they are in pairs. In chemistry, you will come across some exceptions. Nitrogen has some exceptions, but this is not one of them. So you got to keep them paired up. That's number 1. Number 2, we started this lesson discussing the octet rule, and in the octet rule says that elements in column number 14 and to the right must have a minimum of 8 electrons around them. Carbon is in column 14, so it must have 8. If you look at my drawing, this carbon on the left hand side does have 8. Top, bottom, right, left, there's 8. But the carbon on the right only has 6 electrons. 2 there, 2 there, 2 there. It is not following the octet rule, and it must follow the octet rule. So what do? Add more electrons? No, I can only go up to 12. So what do you do when you don't have enough? Well, then you begin to share. So when they share the electrons, that's when you start getting extra bonds. So I'm going to get these 2 electrons right there and share them. There you go. Now that is the Lewis dot structure for this compound, and that would be the Lewis dot structure. Let's go ahead and move on to the next one. Letter C, N2. Looks easy enough, but it's got some issues with it. Sorry, that's letter C, N2. Nitrogen, it's just 2 nitrogen atoms. Nitrogen, you'll find that in column 15, so there's 5 valence electrons, and because there's 2 of them, I add them up, so there's 10. Alright, so I'm going to go ahead and put nitrogens. They're attached to each other. There we have it. We need 10 electrons, so I already have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got my 10 electrons there. Great. Now, did I get my drawing right? No. Nitrogen is in column 15, and again, elements in column 14 and to the right follow the octet rule. That means that they must have 8 electrons. This nitrogen here on the right does have 8 electrons, 2, 2, 2, 2, but the nitrogen on the left does not have 8. It only has 4 electrons. So could I just draw more electrons? No, I can only draw 10. That's it. So what do when I don't have enough electrons? You begin to share. Okay, so we're going to go ahead and take a couple of electrons from here, move them into the bond. So there they are. Now I'm sharing the electrons that were here, move them there. Now they're both sharing it. The the nitrogen on the right still has the 8 electrons. Now how many does the nitrogen on the left have? It has 1, 2, 3, 4, 5, 6. Still not enough. So we need to do more sharing. So I'm going to take another pair of electrons, move it into the bond. Now they're sharing them. Now if you notice, each one has 8 electrons around them, and nitrogen forms a triple bond. And both of these nitrogens are following the octet rule. Alright, let's go ahead and move on to letter D. And in letter D, nitrogen dioxide, we're going to go ahead and take a look at this one. And nitrogen dioxide, I mentioned that nitrogen does have exceptions. Nitrogen is a little bit of a strange atom, so you're going to see an exception for NO2. Alright, so this one has 5 electrons, and it's going to go ahead and have oxygen, which is in column 16, so it's got 6 valence electrons, and I put it twice because there's 2 of them, so it's going to be 12 right here, plus 5 more, that's 17, which is an odd number. That's the first time you've come across an odd number. Okay, so let me go ahead and draw nitrogen. I'm going to put it here in the center with the 2 oxygens around it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, nitrogen does have 1 single electron. And before I've stated on other occasions, say all the electrons need to be paired up. Nitrogen, though, tends to break the rules quite a bit. Alright, now, how many electrons does it have around it? And nitrogen is in column 15, so it does want to follow the octet rule as much as it can. So right now we have 1, 2, 3, 4, 5 electrons around it. So what nitrogen will end up doing is, well, you can share 1 electron from here, an electron pair, put it there, or I could have put it from either oxygen, it does not matter. And there we go, now it has 7 electrons. It won't want 9, in case you're wondering, well, can we give it 9? No, 7, and it'll settle for 7. In this example, it cannot follow the octet rule. It gets stuck with 1 electron. It's nitrogen. Nitrogen is a little bit strange. So, there we go. We got into one of the exceptions. Alright, let's move along to letter E. And in letter E, we're going to go ahead and have oxygen. Oxygen is in column 16. It does follow the octet rule, and it's got 6 valence electrons. There's 2 of them, so a grand total of 12 electrons. We'll put 1 oxygen there, another one there. There's 2 electrons. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's got 12 valence electrons. Again, as I mentioned, it wants to follow the octet rule. The oxygen here on the right, it does have 8 electrons, but the atom on the left does not. So again, the solution, add more electrons. Nope, we can only add 12. So there's only one solution. Get electrons, put them into the bond, so they're sharing them now. Now each one of those has 8 electrons around them. Alright, let's go ahead and move on to letter F, which is our last one for this section. And letter F, H2CO. Alright, for this one we're going to put carbon as our central atom. Alright, and carbon, it follows the octet rule, so does oxygen. Hydrogen on the other side does not follow it. Hydrogen is on this side of the periodic table. Remember, only 14 through 18 must have a minimum of 8 electrons. Hydrogen does not follow the octet rule. Let's count the valence electrons. Hydrogen is in column number 1, so I'm going to put 1 plus 1 because there's 2 of them. Carbon is in column 14, so I'm going to put plus 4. Oxygen is in column 16, so I'm going to put 6. Grand total of 12 electrons. I'm going to put carbon as my central atom. So here we go. Again, I'm going to put electrons on the outside, and then any extras you put them into the center. Now, could I put electrons here and there? And the answer is no. Remember, you cannot put any electrons on hydrogen. Why not? Well, the outer level it's got, it's a 1s outer level, and the s can only handle 2 electrons. And it already has 2 electrons right there in the bond, so it's already full. So I'm going to put them around the oxygen. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. Done? Well, not quite. Remember, carbon needs to follow the octet rule, and right now it's only got 6 electrons. So the solution, same as always, you need to share some electrons. So I'm going to take 2 electrons from there, share them, and there we go. Now, it's following the octet rule. This is also following the octet rule. My drawing's got 12 electrons as well. Alright, now, before we end this section, I wanted to go ahead and also mention a problem that students once posted to me and said, they gave him this same question and he answered it like this. that was my student's answer. And I said, no, sorry, that is not correct. And he was confused. He said to me, but it's got 12 electrons, following the Octet rule. That's following the Octet rule. I didn't put any electrons on the hydrogen, like you said. What's wrong with it? Oh, all right. So let's get into some details. What's wrong with this one? All right, here I mentioned that carbon had 4 valence electrons. So if I were to draw just a single dot diagram for carbon, I will put it with 4 dots. And then if I were to ask you, how many bonds could carbon make? Carbon could make 4 bonds because it's got 4 free electrons. If I were to now give you the dot diagram for oxygen, it had 6 valence electrons. So there you go, 1, 2, 3, 4, 5, 6. Notice that oxygen has, although it has 6 electrons, it only has 2 free electrons. This one and that one. So therefore, oxygen can only make 2 bonds. In my drawing, oxygen has 2 bonds, which is okay. In my student's drawing, oxygen had 4 bonds. Oxygen cannot do 4 bonds. So that's why this drawing could not be. Alright. That wraps up our first part of the lesson on Lewis dot diagrams with extra bonds. The next part of our lesson will focus on the Vesper model of the atom, which is Vesper stands for valence shell electron pair repulsion. What that does, it gives us a pretty good understanding of what the shape of the atom will look like. Okay, so here we have 5 different models of the atom, and they come in linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Alright, now those are the more basic ones, and in our next slide you'll see them a little bit larger so easier to see. The linear will have an angle of 180. The trigonal planar is just a flat triangle, will have an angle of 120. The tetrahedral, it has 4 atoms attached to it, will have an angle of 109.5. Trigonal bipyramidal, we have 2 angles, 90 degrees and 120. And the octahedral, it is 6 atoms attached to 1 central atom. All the angles will be 90 on the octahedral. Now we're going to go ahead and take a look a little bit closer at all of these. Those are the more basic ones. There are a lot more, as you can see, from trigonal pyramidal, T-shape, square planar, and so on. Alright, so let's go ahead and go through these and see how they're slightly different. So I'm going to use my models to go ahead and hold up. This is our first one. It's a linear molecule, so it's a very basic one. In my diagram here, you see it. There's my diagram. The central atom is represented in black here, and the 2 atoms that are attached to it are here in white. And the purple, that's the space where the electrons occupy, and that's where the bonds taking place. So purple here are bonds. Alright, you will refer to these lines as shared electrons because they're being shared between the central atom and the outside atoms. Okay, so these guys would be, you would say it's got 2 shared pairs of electrons. Remember, there's 2 electrons there. So you're going to hear me say pairs quite a bit. So there's 2 shared pairs of electrons. Okay, so that is the linear model. Our next model is a trigonal planar. Trigonal because it's got 3 sides, and notice that it is flat, so it's planar. Again, in black is our central atom, and there are 3 atoms attached to this. Now, again in purple, that's the bond. So this one will have 3 shared pairs of electrons. There's 1, 2, 3. Okay, but it does have variations. In its place, you could have this, where here in gray is a pair of unshared electrons. In our diagram, it will look like that, the shared of unpaired electrons. So for the trigonal planar, which is the first one I showed you, it would have 3 shared pairs of electrons. But once we replace that shared pair of electrons with a pair of unshared electrons, unshared means that there's no atom there that they belong to, they're not sharing them, they only belong to the central atom. So then I would describe this as having 2 shared pairs of electrons and 1 unshared pair of electrons. Okay, it's a name for that one. It's called bent. And you can see that because it is not a straight line, it is a bent molecule. Our next molecule is called a tetrahedral. In this one you have 4 different atoms attached to our central atom, and the angle on it is 109.5 between all of these. Now the funny thing about the tetrahedral, doesn't matter which way you turn it, you'll see that there's always one pointing towards the top. Okay, so it's a tetrahedral. Now, how many shared and unshared pairs does tetrahedral have? It will have 4 shared and 0 unshared. Now what happens if I replace one of these with a pair of electrons that is unshared? It's still, they can form a little bit of an angle there, so it's referred to as a trigonal because it's got 3 sides. Pyramidal because it does make a little bit of a pyramid. Alright, so that would be its name. Shared and unshared will have 3 shared and 1 unshared pair of electrons. Now we can keep on going a little bit further. What if we replace 2 of these? Okay, so that would be look like this. Okay, so it would have 2 shared pairs of electrons here in purple and 2 shared and 2 unshared pairs of electrons. That would be this drawing right here. So 2 shared, 2 unshared. This is what it would look like. And its name is bent. You can see it from its angle. It's a bent molecule. It is a repeat name, as you can see it right here between both of those. So that it will be a tetrahedral molecule. Our next molecule is called Trigonal Bipyramidal. Now that's a bit of a strange name, but if you think about it, look at it from the side, you connect the line from here to there and so on. You'll notice a triangle is there. So from there to there to there, that makes a triangle. And if I connect those tips of the triangle to the top right here, it'll make a triangle, a 3-sided triangle. And on the other side, another 3-sided triangle. So that's why it's bipyramidals. So essentially its name would be 2 3-sided pyramids, Trigonal Bipyramidal. Alright, angles on this one. If you look at this angle, it would just be 90 degrees. But if I turn it sideways, you'll see that the ones on the center, equatorial, near the equator, they're 120. Alright, so it's got 2 separate angles. Now if you begin to replace some of these with unshared electrons, it's going to go ahead and change a little bit. Before we do that though, I wanted to point out, here's Trigonal Bipyramidal. If I ask you how many shared and how many unshared, you would say it's got 5 shared. See the purple ones, they're the shared. They're sharing it with this atom here in white. The central atom's the one in black. And how many unshared? 0. Now, what happens if we go ahead and replace one of those? Alright, so that's going to be this now. So that's an unshared pair of electrons. Name for it, seesaw. Alright, so here it is. How many shared and unshared pairs? It would have 4 shared and 1 unshared pair. If you're wondering the name seesaw, well, you got to use a lot of imagination. But if I place it in my hand and I go back and forth, it kind of resembles a seesaw. You will see the playground. The next one after that, it's going to be T-shaped. Okay, for T-shape, I'm going to replace another one of the shared with an unshared pair of electrons. So here we have it. It will look like this, and if you use your imagination, you can see there's the T right there. So it's called T-shaped. Okay, and the last one is linear for this one. Alright, so our linear molecule would have 3 unshared pairs of electrons, so I'm going to remove another one, replace it, and there you go. There's your linear molecule with 3 unshared pairs of electrons around its equator. Alright, so that would be a trigonal pyramidal with 5, 4, 3, and 2 shared. And for this one, we'll have 2 shared and 3 unshared pairs of electrons. For our last type of molecule is referred to as an octahedral. Now this octahedral, you might look at it, it has 6 shared pairs of electrons, which is a bit of a strange name, octahedral, octa meaning 8, for a molecule that has 6 atoms attached to it. So if you're wondering why is it that it has 6 atoms attached to it, but it's called octahedral, well, you're going to have to use your imagination a little bit. Again, if I hold it up like this, you'll see that that makes a square. And if you connect those to the atom that's coming towards you, that will give you a 4-sided pyramid. And what's on the other side? Another 4-sided pyramid. So 2 4-sided pyramids, so 4 plus 4, that's what goes ahead and gives you your 8. Now, let's start replacing some of these and getting its name. Let's take up this one on the top, and if I put this one down, now it's got 5 shared, so you see the 5 purples and 1 unshared. Name for this one is square pyramidal. I go ahead and I replace one more, Now it has 4 shared, so you see in purple the shared electrons, and 2 unshared pairs of electrons. Name for this one is square planar, because it does make a square and it is flat. Alright folks, so those are all of the names in the Vesper model. Alright, now up next for us, we're going to go ahead and solve some problems. We're going to get some molecules and try to identify what they are. Is it trigonal planar, trigonal pyramidal, or a seesaw? That's what's up next for us. Up next for us, we're going to go ahead and solve some problems where they give us a molecule and they ask us to identify, is it a tetrahedral, is it a trigonal bipyramidal, and we have to identify the name of the shape of the molecule. Alright, so we're going to go ahead and use these molecules that are here. Now these molecules have been covered in previous lessons on how to solve for the Lewis dot diagram. So I'm just going to go ahead and display the Lewis dot diagram and work from there. So first one is A. A is HBr. So here's this Lewis dot diagram. It's got one single line, so name for this one is just linear. Up next is letter B. And for letter B, we get the molecule CF4, carbon tetrafluoride. The Lewis dot diagram for this molecule looks like this. For the central atom, we count how many shared electrons, so that's the line, that's a bond. So it's got 4 shared and 0 unshared. So now you start looking, and the answer is this one right here. It's got 4 shared and 0 unshared pairs of electrons. So the answer for letter B is tetrahedral. Next is letter C. The molecule Bi3, boron triiodide, is given to us. Here's the Lewis dot diagram for it. If you look at the central atom, it's got 3 lines coming out of it, so it's got 3 shared electron pairs, and 1 pair on the top that is unshared. It belongs only to the central atom, so 3 shared, 1 unshared. That will be this molecule, Trigonal Pyramidal. Next for us is letter D, and letter D gives us NF3, which is nitrogen trifluoride. Here's the Lewis dot diagram for nitrogen trifluoride. You'll notice 1, 2, 3 shared electron pairs are being shared between the fluorine and the nitrogen. And a pair of electrons that is unshared, they belong only to our central atom, which is nitrogen. So our central atom's got 3 shared pairs and 1 unshared pair. So that would be this one right here, trigonal pyramidal, with 3 shared pairs and 1 unshared pair of electrons. Letter E gives us the molecule CaCl2, which is calcium chloride. Now, here's the Lewis dot diagram for it. And the central atom's got 2 shared pairs, but no unshared pairs. So only those 2. So 2 and 0. That'll be this molecule, 2 shared, no electrons on top or bottom. So the answer for letter E is linear. Next is letter F. And letter F gives us the molecule PBr3. So that's Phosphorus Tribromide. Here's the Lewis dot diagram for the molecule. You'll notice that it has 3 shared pairs of electrons, and on the top it has 1 unshared pair of electrons. So 3 shared, 1 unshared. The answer for that one is Trigonal Pyramidal. Next is letter G with PCl5. That's Phosphorus Pentachloride. Here's the Lewis dot diagram for Phosphorus Pentachloride. And you'll notice it has 5 shared pairs of electrons, but the central atom has got no unshared pairs. So that would be this right here, trigonal bipyramidal, with 5 shared pairs and no unshared pairs of electrons around the central atom. Next is letter H, which gives us SF4. That is sulfur tetrafluoride. Now, here's our dot diagram for it. You'll notice that it has 4 shared pairs of electrons and 1 unshared pair of electrons. So 4 and 1. So that will be this right here. Seesaw is our answer for sulfur tetrafluoride. Letter I is ClF3, chlorine tetrafluoride. In this molecule, this is its Lewis electron dot diagram. You will see 3 shared pairs of electrons and 2 unshared pairs of electrons around the central atom. So 3 shared, 2 unshared, that will give us T-shaped. So that's the answer for letter I. For letter J, we're giving the molecule BrF3, bromine trifluoride. Here's a Lewis dot diagram for it, and again it's got 3 shared pairs of electrons here, there, and there around the central atom, and 2 unshared pairs of electrons around our central atom of Br. So 3 shared and 2 unshared, that will be once again T-shaped. Up next for us is letter K, XeF4, that is Xenon Tetrafluoride. In the Lewis dot diagram, you can see that it has 4 shared pairs of electrons and 2 unshared pairs of electrons around the central atom. So 4 and 2, that would go ahead and give us square planar as the answer for XeF4. Last for us is letter L, which gives us SCl6, sulfur hexachloride. So here's its Lewis dot diagram. You look at the central atom and you count how many shared pairs of electrons and how many unshared. It has 6 lines, those are the bonds, so they have 6 shared pairs of electrons and no unshared pairs of electrons around the center atom. So what is the name for this molecule? It would be an octahedral. This brings us to the end of week 11 in unit 2. Thank you for watching.